Hello everyone, my name is Sumit Shrestha and today I'm going to present paper review on incorporating expert-based investment opinion signals in stock prediction, a deep learning framework. This is the basic overview of this paper review presentation. Investment messages published in social media platforms are highly valuable for stock prediction. Study done in this paper provides an in-depth analysis of public stock reviews and their applications in stock movement prediction. Specifically, this paper proposes a framework which includes time-sensitive and target-aware investment stance detection, expert-based dynamic stance aggregation, and stock movement prediction. In stock market, public comments are of great value in reflecting market conditions and making trading decisions. One of the example is the figure here shows trading volumes of Huai Brothers and China Fortune, which are two stocks in Chinese Asia market, and the amounts of their relevant reviews from Shuachu and Gyuba, the two popular Chinese Twitter-like investment forums. In Figure 1a, both the reviews amount and trading volume of Huawei Brothers peaked on June 4, 2018 as a result of the celebrity twin contracts incident. The sudden increase in Figure 1b of China Fortune indicates an important policy announcement on April 1st, 2017. Shortly after the news release, a lot of comments were generated from the public and related shares witnessed a rapid rise. This shows that it is reasonable to leverage public opinion signals for stock prediction. There are three major components regarding the architecture for the framework. The first one, a stance detection network named MFN to determine bullish bearish investment opinion signals from public reviews. The second one is a stance aggregation module to identify and aggregate high-quality opinion based on dynamic expert mining procedure. And the third one is a stock forecasting module which combines expert opinion indicators to predict the future movement of individual stocks. The next few slides, I'll be discussing more about these three major components of the framework. The first one is the stance detection. It uses multi-view fusion network, in short MFN. As I said earlier, MFN determines bullish bearish investment opinion signals from public reviews. MFN distills multi-view semantic feature from words, engrams, and structured matching sequence with two encoders, word level encoder and TPO encoder. The first, for the word level encoder, there are three steps. In the first step, the raw input of a stock review is transferred into matrix. The matrix contains associated knowledge attributes including time, polarity, and negation through matching the already created lexicons in financial domain. At the next step, CNN layer is used with varying window sizes to distill n-gram local patterns in the text. In the final step, max pooling operation is then adopted to extract the most noticeable or important features. The second encoder used for this stance detection is TPO sequence encoder. TPO stands for time, predict, and object. Basically, there are three steps. At the first step, time, predict, and object is extracted from stock review. One of the examples of TPO extraction is, suppose following stock review was made. At Lee, do not chase LETV at present. There is excellent time to buy GREE. By the way, SAIC motors will pick up soon according to the theoretical calculation. Here, time, predict, and object sequence extracted from example is, at present, do not chase LETV. This is excellent time, buy GREE, will pick up SAIC motor. The second step is, for each triplets extracted from review, is aligned and stacked to construct the TPO sequence like a 2D image, where each aspect serves as a feature channel. And at last, like word level encoder, CNN layer is used on multi-channel input metrics with varying window sizes, and max pooling operation is then adopted to model the interactive relationship of the multiple matching tuples. The final stage of the stance detection is the stance prediction. The probability G of RS is calculated through a single layer perceptron with softmax function using an output vector that are learned from two encoders, the word level encoder and the TPO sequence encoders. The final model is learned by minimizing following loss functions. Here G is the model, R denotes review content, and S is the targeted stock. Y is the level indicating whether the author holds a bullish, bearish, or neutral view towards the stock as in review R. This slide shows the overall architecture of MFN stance detection. Here it shows that the information is concatenated from both the encoders and the probability is calculated using softmax function. Now the next step after the stance detection from the framework is the expert basis stance aggregation model. Stance aggregation model identifies and aggregates high-quality opinions based on dynamic expert mining procedure. This slide shows the algorithm used for the model. A user is judged if he or she is an expert on the stock based on the predictive accuracy of the stock movement. First step is to aggregate the reviews written by users U on stock S over a past period of time E, and leverage the proposed MFN model to determine users' bullish bearish predictive position for each review. Then the result is aligned and compare the opinion indicator with the practical stock price variations. The forecasting opinion is correct if a bullish review is followed by a stock price rise or a bearish review is followed by a fall. Here, CUS and IUS is the number of correct and incorrect predictive opinion. The accuracy of user towards the stock is defined as number of correct predictive opinion, that is CUS, over number of total opinion, that is CUS plus IUS. Now the final stage of the framework is the individual stock prediction module. With historical time series feature for stock, the goal is to measure the probability of the stock price to rise or fall on the particular transaction day. To model the sequential relationship of historical trading indicators, gated recurrent unit (GRU) is used to encode the feature sequence in chronological order. The GRU will filter out how much past information is needed to be passed along to future and how much past information to forget using update and reset gate respectively. And finally, softmax function is used to determine probability of stock to rise or fall. As for the experiments done for the framework, there are two groups of experiments done for a better insight into how each model affects the performance of the framework. The first one is to evaluate MFN for stance detection on the real-world investment reviews, and the second one is to perform individual stock prediction to investigate the effectiveness of the expert-based stance aggregation model and the forecasting model. The first experiment is the stance detection evaluation. For this, real-world dataset was used that includes around 165 million reviews written by around 6 million users from Cuba and around 6 million reviews by around 200,000 users from Suachu involving 3,500 stocks was used. Next step was to randomly select 20,000 reviews from the large corpus and recruit 3 labelers to annotate each review into 3 classes: bullish, bearish, and neutral. For this experiment, weighted F1 value was used on both 3 classes, that is bullish or bearish or neutral, and 2 classes test, that is bullish or bearish, was used as the evaluation matrix. An evaluation and comparison of MFN with other baseline method and variance was done. As we can see in this slide that MFN outperforms the baseline methods more than 2.5% on 3 classes evaluation and 3.5% on 2 classes evaluation. Also in this chart, MFN without TPO and MFN without KE are MFN without 2 encoders respectively. The experiment shows that even without the 2 encoders, MFN can still perform better than baselines on the 2 class evaluation. The second experiment done is for the stock prediction evaluation. To evaluate the effectiveness of each module in the prediction framework, 3 types of features are designed, that is FSPC, FSALLR, and FSEXPR. Historical price feature of open, high, low, close, volume, and CSI 300 index are set as a baseline, that is the set of FSPC. The other 2 methods incorporate the derived investment opinions. FSALLR uses all public reviews equally, while FSEXPR involves only a high-quality opinion screened through the expert mining procedure. For this, dataset is divided into training, validation, and test set, and experiments were performed on 12 well-known individual stocks In China, A share market that includes Greece, CCV, 1K, SAIC, Moros, etc. As for evaluations, two metrics are used: the standard measure of accuracy (ACC) and the Matthews correlation coefficient (MCC) to evaluate individual stock prediction. Finally, we can find that incorporating expert investment opinion (FSEXPR), that's the blue bar, can consistently achieve the best performance on the two metrics. For some stocks, the accuracy is quite high, such as 67.78% for Sunning and 65.38% for CYPC. Also, by comparing FSALR, that is the red bar, with FSPC, it demonstrates that in most cases FSALR performs better than FSPC. This concludes my presentation on paper review. Please let me know if there is any questions. Thank you.